Hey. Ratios and proportions. The whole reason we're doing this is because you're going to be solving a lot of equations like this. Okay? You guys remember what a ratio is?
Yes.
What is it?
It's like something over 100 is.
Ratio is when you compare A to B. That's one way to write a ratio. They also use a semicolon to write a ratio. The most common way, and what you're used to seeing, is simply this: A over B. A mixed number is not a ratio because there's a number in front, right? Ratio is something over the other one. Proportion. When two ratios are set equal to each other. Example, A over B is equal to C over D. That is an example of a proportion. Proportions are very, very handy. This is called your mean, this is called your extreme. That's not so much as important. What we're basically talking about in this section is reminding you how to cross, multiply, and solve a proportion. Cross, multiply, and solve a proportion. If A over B is equal to C over D, then what can I say? A times what? D is equal to B times C. However, it has to be in the form of a proportion for you to be able to cross multiply. Everybody always, they see two fractions and think, oh, I can cross multiply. Well, not if you're adding them together. You can only cross multiply when they're a proportion, when they're set equal to each other. Okay? See if you guys can solve this. I know you guys can do this in your head. I could care less. What had I better see on your homework? I'm testing whether you can cross multiply and solve, not whether you can look at it and figure it out. Okay? Everybody try this. See if you can solve that. Okay, what'd you guys get here? What are you gonna do? Cross multiply, you're gonna multiply this x times this 12, and get what? Equals. And you're gonna multiply this 4 times what? This 8, what are you gonna get? Everybody see where we got there? Now, it's a pretty easy equation to solve. And I wanna see the equal sign, I wanna see it move down. What am I gonna do now? Divide by?
12.
And you get x is equal to what? Okay, let's reduce that to,
6 repeat.
how about
8.
4 goes into that 8, 4 goes into that 3. 8 over 3.
That's my bad.
Okay?
Wait, what?
Reduce it to an improper fraction. Okay? Reduced improper fraction. If you don't start with a decimal, don't end with one. Unless I tell you you can. Right here. What am I going to do? First of all, 9 times what? 15. What do I get?
130.
Is equal to
10x.
x times 10. 10x. Divide both sides by what?
10.
X is equal to, well, 5 goes into that 2. 5 will go into that how many times?
A lot.
2 with 3, 27. 5 goes into 10, 5 goes into that. I'm taking the common factor. I'm reducing the fraction.
Yeah, but you guys want decimal.
No decimals. If you don't start with a fraction or a decimal, don't end with one. You guys might as well get used to that. Now, you have buttons on your calculator that will do that for you.
What if you thought of it as like, I mean, once you get 27 over 2, 2 can go into 27 like.
But I'd rather you leave it as improper fraction. The only time mixed numbers are handy is when talking about measurements or when you're talking about plotting points, because then here you would know to go to the right 13 and a half. You know what I mean? But for using it as knowing that x is equal to that, plugging it into another equation, so on and so on, when you get into higher level math, this is much more handy to have than a mixed number. Here, concept has not changed at all. Every single time we've multiplied what was on top times what was on bottom down here. This does not change. So what you guys need to realize here is this is 4 times the quantity, in parentheses, x plus 4, is equal to this whole thing times this whole thing up here, 3 times the quantity, x minus 5. Now, come back over to here, multiply through, what do I get? 4x plus what? 16 is equal to,
3x minus 15.
come in. Come in. Now, subtract 3x from both sides. X plus 16 is equal to negative 15. Subtract 16. X is equal to a negative 31.
Can I see Joshua Batchelor and Dylan Carmichael and Martin Alba and Sean Thompson?
Bachelor's not here.
Yeah.
Is that everybody? Hey, close it, Sean. Okay, you guys see what to do?
Yes.
That's all there is to it. Yeah, you just learn how to solve